What's up, everyone? Welcome back to the Routing Loop 2026. It feels really unnatural to say 2026. I think that happens all the time, but 2026 just seems way, way, way out in the far-reaching future. Hey, Sid, what's going on, man?
Hey,
Welcome back
Matt.
to
Good.
the Routing Loop.
Yeah. Yeah. Thank you. Thank you. Yeah. Looking forward to 2026. Yeah. Still getting used to 2026. I keep saying 2025, but uh, yeah, it's 2025 was an interesting year. Um,
Yeah.
a lot of good stuff. We just came out of reInvent, so there's a lot to talk about. But yeah, looking forward to 2026 as well.
Yeah, I think the upcoming sessions that we normally do at the start of the year are generally chalk talks. So I love chalk talks at reInvent. I think they're probably the most valuable sessions you could do. Breakouts you can watch on YouTube at 1.25 or 1.5 speed, maybe depending on how fast the speaker talks, or how well you know the topic. Chalk talks are where good stuff happens that doesn't get recorded. So really good questions and whiteboarding and all of the juicy stuff. So I think what we normally try and do is the first couple of sessions for the year on the routing loop for folks that may not have gone to Chalk Talks at reInvent or may have not have gone to reInvent at all is try and redo some of those Chalk Talk topics. But today, first session back for the year, January 7, we thought we'd do something a little bit different just because AWS Cloud WAN released a routing policy feature, which I think is pretty game changing. And Sid, I know you did a session at reInvent. We can throw a link into the chat. Maybe I'd have to log into Twitch here. I think I'm logged in, but I think routing policy really gives a lot of control back to folks that want to manage their routing or packets flowing over their Cloud WAN network. Do we call it a Cloud WAN network, or what do we call that? I mean, it's a segment,
Yeah.
but
The routing policy, you mean, or
no, I mean, let's
segment?
say
Yeah,
you're
that's a
using
segment.
cloud. I guess you just call it Cloud WAN. I'm using Cloud WAN because, a traditional wide area network, you'd say, "Oh, I'm using my WAN," or "That's my WAN connectivity," or "That's my MPLS network," or something like that. With Cloud WAN,
Yeah.
it's all AWS, right? I'm using Cloud WAN.
Yeah, and you create a core network. I mean, we call it core
The
network,
core.
but it's very much a WAN, wide area network.
Right, right, right.
Yeah,
Yeah, I think the premise of Cloud WAN was really we were seeing folks using Transit Gateway, and Transit Gateway was an amazing feature when we first launched that back in when was that 2017, 2018, somewhere around there. I
yeah,
think it was 2018, and it basically gave you control of connectivity for all of your VPCs. So you could do route tables within the Transit Gateway and control advertisement of routes and some other good stuff, and have up to 10,000 routes. And it was game changing versus the old transit VPC architectures using a virtual router and VGWs and that sort of stuff. But what we saw was that folks were using Transit Gateway to build global networks. And so when we could do Transit Gateway cross-region peering, it was like, okay, now we can connect all of these Transit Gateways together in a mesh, and things got pretty complicated pretty fast. So hence Cloud WAN was born, built on top of Transit Gateway to basically simplify a lot of that, to basically just say, okay, I'd like to go global and just use a core network to interconnect all of my VPCs without having to manage a transit gateway in every region. So I think Cloud WAN was pretty game changing there. But I think as network folks like you and I are, I guess there was a want for things like BGP policies and a little bit more control and levers and knobs to say, hey, actually, I want to do something specific here. And that's really where routing policy comes into play. So how about give us a bit more depth, tell us how to use it. And I think maybe we might dive into a console maybe if we're feeling game and just see how
yeah.
it
I
works.
think I set up a bunch of demos for reInvent, and then I haven't touched them. So we'll see if
If they still
those
work.
demo environments have survived, and if they still work. If there's any like the spider webs in there, we'll see. But you're right. When we released Cloud WAN, one of the most important things and the most powerful things was policies. So you can define your entire network using policies. And as we're thinking about, it's a great time to think about the future because we are entering into a new year, and you think about where networking is going and how the next few years would look like heading into maybe the next decade. Everything is becoming policy driven. So you define a policy, you define your intent, and the network automatically changes to match your intent. And that's where Cloud WAN is really powerful, because you can do that. And now with these routing policies, you're getting much greater flexibility and capability to tweak how your packets are flowing. And again, it's all based on policies. Some of the concepts might feel familiar to like route maps and stuff, but again, the way you configure here is all based on intent and policies. So I have few slides. So I'll probably let's just look at some of the slides as a reference point. But again, we want to make this interactive. So if you, the folks who are watching, if you have any questions and stuff like that,
Yeah,
feel free
please
to
post the
get that.
questions in the chat. That'd be great. Good to see some familiar names there. Tech First, Hirings, Ken, Tech First. Tech First actually asking if it's possible to do the demo or to do this in 2 parts with the demo, because it's a great feature. We'll see if we run out of time today. We haven't got next week set in stone, so if we need to steal next week for more Cloud WAN stuff, maybe we can. We'll see. But
Yeah,
we'll
we
see
can.
how we go.
Yeah, we'll see. All right, so let's go ahead and share the screen. Okay, perfect. I see it's up. Okay, so I'm not going to spend time talking about what Cloud WAN is and how it works. I'm just assuming you guys are aware. But here's what a Cloud WAN network looks like. We have a Cloud WAN core network, which is extended into 3 regions here: US East 1, US West 2, and EU West 1. And then we have this concept of segments, right? These are globally routable boundaries, but they're isolated in the sense that by default, uh, the attachments or the networks which are associated with the segment can only talk to each other, and you cannot route traffic between segments unless you explicitly state that. And you can connect everything to Cloud WAN, right? You can think of from a network standpoint. So here we have VPCs, we have our on-premises networks via Direct Connect, IPsec VPN, site-to-site VPNs. We have SD-WAN connectivity via tunnel-less connect, where you can set up GRE tunnels, or like you don't need any tunnels, and you can just set up BGP peering between your CNEs and SD-WAN appliances. And then you can also connect transit gateways to AWS Cloud WAN. Now you can see these routing sort of routers in every region. These are CNEs, or core network edges. So these are the local, highly redundant, available routing entities within a region, and they control how routing works. So you'll hear me talk about CNEs quite a bit in this session. So this is what
I imagine a CNE is like a managed transit gateway. That it's a similar kind of construct, right?
That's correct. Yeah, it's using exactly the same technology which Transit Gateway is built on, and that's the fun piece, like innovation within AWS is we invent a certain technology, and then that's sort of reused in different services. I remember. I think we developed this flow hashing thing first for like S3 load balancer, which then was incorporated into like an NLB, and then the same technology was used to build transit gateway and stuff like that. So it's I think
we should do a session on that. Maybe we can whiteboard that one out. I think the umbrella term is hyperplane. If folks want to do any search on that, yeah, the hyperplane piece is an umbrella term that we use for a whole bunch of different stuff that stacks into a massively scalable packet processing thing. So it's incredible. But yeah, we've reused that in a lot of different places, and it's no different here.
Yep, exactly, hyperplane. All right, so when we set up this network, there's a lot of routing happening. So the CNE within a region is going to learn routes from all your different networks. From a VPC, it's dynamically going to understand what the VPC CIDR is, or the secondary CIDRs are. And it can also understand routes using BGP over attachment. So, over Direct Connect or IPsec VPN, you set up a BGP peering relationship with your on-premises routers. So it's learning all of those routes. Then you have SD-WAN appliances. If you set up tunnel-less connect, it's learning BGP there. and it's also learning BGP from transit gateways. Or transit gateway does not support BGP natively, but when you connect it to core network edge on Cloud WAN, it does exchange routes using BGP. So that's really cool. Then the CNEs also exchange routes with each other across region, right? So they're fully meshed. So every CNE has a BGP peering relationship with every other CNE, and they're exchanging routes. And then finally, when you enable segment sharing, routes are being shared between segments as well, and that's also via BGP and dynamic routing, right? So here we are sharing hybrid routes with production and development. So you can see that's BGP peering as well. So you can see there are 4 distribution points for routes. One is, which is run from the VPC. Second is BGP over whole array of attachments. Third is inter-region BGP between CNEs, and fourth is cross-segment BGP. Now, this is great, really powerful, but you can already see there's like a lot happening here, and then if things are getting exchanged all across the place, it gets a bit difficult to manage and maintain, and you can encounter some uncontrolled route propagations. So I think, Matt, you were going to say something.
Yeah, I was just going to say something similar in that we've recreated a lot of concepts that are familiar to on-premises MPLS networks with multiple VRFs and multiple route targets and importing and exporting routes. And I kind of just had a cold shiver there for a second, because I was remembering once I added a default route into a VRF and didn't realize that about 3 or 4 VRFs along, I hadn't put a no export statement, and it basically propagated this route all through the network and sucked a whole bunch of traffic into my VRF that I was creating, and took down a whole bunch of subscribers in a mobile network, not in this job, in a different job. So things get complicated, and I could see us having the same problems here, right, with all of these route exchanges going on.
Exactly. You summed it up well. You put a bad route into your VPN from on-prem, and that gets learned by the CNE, but then it's also advertised across segments, across regions, and it can create a mess. So only if we had some kind of a mechanism to filter out routes and restrict out propagations. With BGP, it's all or nothing. The way it is in the picture right now, it's all or nothing. Like BGP is going to learn routes and just advertise it all or nothing. You don't have like fine-grained control, and that's what we're trying to fix here. So the other challenge which we saw was indeterministic traffic patterns. Again, when you have like multiple routes to reach the same destination, then BGP path attribute priority takes into effect. But a lot of times, you don't have the ability to control that. So we want to fix that. There's a lot of routes being learned from a lot of places. And, sometimes this can exceed thousands of routes, even tens of thousands of routes. And, you start hitting limits and have performance issues and stuff like that. So, we want to give you more control there. And finally, when things go wrong, how do you troubleshoot? Right? Which BGP had this issue? Like, what's going on? Where did the propagation happen? Where did it go wrong? Stuff like that. So we are going to fix all these problems with this new announcement. So what we're going to give you is one fine-grained routing control, so you can set your routing in a very deterministic manner. You can use these controls to optimize traffic patterns in multi-path environments, and we're also giving you much more visibility than before to see exactly what's being propagated, what's being learned, what BGP attributes are being transferred from one point to another, etc. Okay, so the routing policy has basically 3 broad categories of functionality. The first is the ability to filter routes. So here, you can allow prefixes or drop prefixes. Right? So as you're learning prefixes or advertising prefixes, inbound, outbound over VPN, direct connect, transit gateway peering, or connect attachments, or as you're learning routes from VPCs, or as you're advertising them across segments or regions, you can match or based on a specific rule and then drop traffic. The route summarization, allows you to basically summarize routes, right? Again, you can match based on prefixes and say, instead of advertising these thousands of routes, only advertise this summary route. And then BGP property modification allows you to manipulate BGP attributes. So you can say, hey, replace this ASN or add this ASN or change the MED value, right? Stuff like that, or add a community or remove a community, or make a routing decision based on a community, right? So it really opens a lot of possibilities. And um, today's session, we'll walk you through some examples of how you could use it. But again, the possibilities are endless. You can use this to come up with your own strategies on how you want to manipulate traffic flow.
It's good to see that the BGP path selection algorithm is still relevant. Pro tip for anyone who's interviewing at Amazon and you get me as an interviewer for the phone screen technical interview, that's one of the first questions I ask. Tell me about the BGP path selection algorithm, because it's still so current today, right? Everything depends on that.
Exactly. Yeah. And you'll see as we go through the slides, BGP is the most important protocol because everything still runs on it. Okay, so how do we get started? So the step one is you want to manipulate routes. That's the whole purpose, is to manipulate routes. So you need to define which routes will get manipulated or modified. So for that, we define a routing policy and we define a match condition. Right? So you want to match a specific route which you want to modify. So match conditions can be based on these values. So you can match on a prefix. You can match on prefix insider. You can also have prefix lists already predefined, so you can just match on prefixes in the prefix list. You can match based on ASN, BGP communities, or even MED value. So you can see that you have a lot of flexibility on how you match a specific route. Once you match a specific route, you define a modification action. Right? So it's pretty intuitive. You define a match condition and define what happens when the route gets matched. So the modification action allows you to drop routes or allow routes if you have an explicit deny. You can summarize your routes. We spoke about route summary as one of the capabilities. Then you can also do BGP path attribute manipulation, right? So you can prepend ASNs, remove ASNs, replace ASNs, add, remove community, set MED values, and also set local preferences, right? So pretty much everything can be done here, as what you would do on like a on-prem router if you're manipulating like BGP and stuff like that. So I'll show you an example how a policy looks like. So what we'll do is we'll do a prefix equals match, and then we'll drop that prefix. So here you can see on the right, we define a routing policy name, outbound route filter. We also give a routing policy direction. So direction is pretty important because, as routes are being advertised, so keep in mind that these policies are applied on a CNE, the core network edge. And the policy defines when the CNE applies this policy. So when the CNE is advertising routes to, let's say, your on-prem router, right? So that's an outbound direction. So you would apply outbound policy if you want to filter that. If you want to filter routes as the CNE is learning the routes from on-prem, then the direction will be inbound, right? So this policy is applied from the perspective of the CNE. So you want the CNE to apply while advertising out or while learning in. That's how the policy direction becomes important. So you match here based on a prefix, so 192.168.0.0/16. And if we see that prefix, we drop it, right? So a simple use case here would be, let's say you have like overlapping CIDRs and you already have a VPC with 192.168/16 range in your AWS environment. So you want to make sure that you're not learning this route from your on-prem and cause any overlapping CIDR issues, right? So you basically
Sid,
just
we've got
drop it.
a couple of questions here. So one from Tech First, and maybe Jeff, you can bring these up. I can't click on them today. Modifying BGP local communities like 7224:7100 on Direct Connect is supported.
So you can, right? The thing about 72, so that specific community, I think, is used for our own scope, right? I'm trying to recollect how we use that community 7271. Is that something which we at Mara, maybe you can check, but you can pretty much manipulate any community, but they obviously there are some restrictions. So if AWS is using some communities behind the scenes to define the scope, etc., then you're limited there. But otherwise, yeah, uh, you can make changes. Now, keep in mind there are some limitations at this release. Not everything is supported. One of the things which is not supported today is actually a community on Direct Connect. That's something which we are looking at for future. But as of today, you won't be able to make community changes on Direct Connect. Community changes are supported on like SD-WAN appliance, SD-WAN connectivity and stuff like that.
Okay. Next question from Ken was, can these policies apply between segments, or they only apply to attachments?
They do apply to segments. So I'm going to talk about that next. So here we're talking about how do you match and how do you modify. But we do need to apply this match and modification to a route distribution point. So I'll talk about that next.
Okay, we'll get there. All right, let's keep rolling.
Okay, cool. So we're right there. So we defined a policy to match and drop, but we need to associate this policy to a route distribution point. And we already saw there are 4 distribution points, right? One is from the VPC, one is over an attachment, one is inter-region advertisements, and fourth is segment sharing. So I'll show you one by one how do you do that. So we'll talk about inter-segment route share, right? Because that was exactly what the question was. So let's prioritize that. It's very simple. You already have a segment action share to share routes between segments. When you do that, all you need to do is just reference the policy name. So here you can see segment action share prod with dev, and I put a mode attachment route and just put a routing policy name and outbound route filter. So once I do this, as traffic is being shared from prod to dev in the outbound direction, this the specific prefix will be matched, and if it's present, it will be dropped, and dev will not learn that prod VPC CIDR, right? So it's a very valid use case where you might have specific VPCs for some compliance reason. You don't want that to be advertised into the dev segment. Very well, you can do that, and you can use this kind of a policy to restrict those specific CIDRs. And I have some examples similar to that, which I'll talk about. So the second distribution point is intra-segment between regions, right? So between region 1 and region 2, routes are being advertised. How do we filter that? So here we have a new segment action where you specify associate routing policy, the segment in which you want to filter, the source region, the destination region, and then you reference the policy. So here's an example. Action associate routing policy for segment prod between edge location US East 1 and peer edge location US West 2, apply the policy outbound route filter, right? Again, the direction becomes important because here we are going to filter routes which are being advertised from US East 1 to US West 2, right? So if you want to filter routes which are being advertised from US East 1 to US West 2, the direction has to be outbound. If you want to filter routes which are advertised from US West 2 into US East 1, then the direction should be inbound, right? So this edge location is where this policy is being applied, or the CNE where the policy is being applied. So the direction is an important thing to keep in mind. All right, so the next distribution point is attachment, right? So we saw how you do it inter-region, inter-segment, and now attachments. So for attachments, we have a new construct called a routing policy label. So you first define a label, and you map the label to the routing policy, right? And then you attach the label to the attachment, right? So when you map a routing policy to a label and then specify that label over attachments, any attachment which has that label will automatically get that policy, right? So it's sort of a hierarchical thing. So here's an example, right? So you associate a routing policy label to an attachment here, right? So we are saying the routing policy label is attachment route filter. And then in the routing policy, we are mapping that label to our actual routing policy, right? So it's sort of a two-step process. This will give you a better clarity, right? So we have our routing policy, and you can have multiple routing policies. We map those routing policies to a label, and then we apply that label to an attachment, right? So you don't apply the routing policy directly to the attachment. The routing policy label becomes like a middle entity to connect these two, right? And this gives you this flexibility where you can have multiple policies applied to a label, single label, and then a single label can, get attached to multiple attachments. So you can play around with this and figure out a strategy on how you want to do it.
So quick question from Tech First: on routing policy can override the routes shared through segment sharing, right? Question mark.
Correct. And I'll talk about towards the end, if we have time, the route priority of how things work. But keep in mind that when route sharing happens, right, CNE is learning the routes, right? So maybe just use this as an example, right? So the diagram on the right, you can see the two CNEs and the route distribution points. So when the CNE, let's say it's learning the route from a different CNE, right? It learns the routes, it applies, and keep in mind there's two. If you worked with like traditional routers, there's like two routing tables in a router. One is your RIB, which is your routing information base, and the second is the forwarding table, right? Routing information base basically contains all the BGP data which is being received by the router. And then it looks at all that raw data, figures out like which route takes priority, which has the highest local preference, which has the best MED values, lowest ASN, etc., etc. And then it figures out what it should put into its forwarding table. Right. So if it has 3 paths to reach the destination, it will figure out the best path and put it into the forwarding table. Right. I hope so that's understood. So the CNE between the RIB and the forwarding table is where it applies the routing policy. So it'll get all that data into its RIB, and then it will use the BGP data as well as your routing policy to figure out what it should ingest in its forwarding table. Now, the good thing, what we have done is previously we only exposed the forwarding table, but now with this release, we also show you the RIB. So you can actually see all the raw information a CNE gets, and then you can also see what was ingested into the forwarding table, right? So I'll show you some demo of that if we have time.
I think those constructs make so much sense, and I'm really glad that we're exposing that now. I didn't think in AWS I'd be thinking about the RIB and FIB again, based on old iOS kind of hacking around and what landed in the FIB and etc. But no, I think this is a really good step in the right direction to say, hey, there is I don't know if it's not the same as a control plane and it is a data plane, but it almost is, right? It's say this is all the data that we have, and now we're going to select what the best path is to use here, as opposed to just this is the best path and that's what we're going to use.
Exactly. Yeah, and you can see I have some screenshots here. Although we can just jump into the console and see this as well, but you have this RIB which is new, You click on it, and you can sort of specify which segment and which location you want to see the rib for, and then you click routing information, and you can see, here you have your prefixes, you have your next hop. Oops. And you also have, if there's any local preference values, AS path, MED values, community, etc. Right? So it gives you the entire sort of visibility into your rib, and obviously the forwarding table is separate. So you can see, as an example here, right? You can see the 10.100/16. There are 3 routes. One through EU West 1, there is one through US East 2, and there's also one through US West 2. So a CNE can, as I said, all the CNEs are fully meshed together. So every CNE is going to have like redundant routes by a different other destinations, and you can see exactly what's being received. When we expand on the AS path, it will show you exactly how many AS numbers are in the path, etc. Communities, and I'll show you some demos. You'll see how it works.
I'm so glad we called it a routing information base and not some other strange, obscure name like we normally do. So using the terms that networking folks are used to just helps you understand this so much easier than otherwise.
Yeah, exactly. So I have some use cases. I know we have 30 minutes left. So what I'll do is, in the interest of time, I'll walk through one use case, and then we'll just jump into the console. Actually, if you're just talking about one use case, I might just pull up a more advanced use case, or maybe not the one which I have here, something different, because I feel this might be a better one. Restrict. Okay. I think I need to reshare. Give me 1 second.
If there's any questions in the meantime, feel free to post them in the chat as well. I know this is a more complex topic that, it's hard to cover this in just an hour. Probably do need to have subsequent sessions on diving in on how this stuff works and different use cases. But
yeah, exactly. What I'm going to do is I'm just going to share my entire screen here. So I think it's just easier that way. Oh, yeah. Matt, let me know once my screen is sharing.
Yep, looks like we're good. Oh, we can actually, we can see your slides right now.
You don't see full screen?
No, just the slides. Oh, wait. Now we see the full screen. The slides are in the background. I just saw your menu bar for your Mac thing.
Okay,
So
but it's
the Mac dock.
It's full screen.
But we only see the PowerPoint slides. Is there a Chrome window or something you want to share, or?
Yeah, actually, I'll just maybe revert to what I was doing before.
Okay.
Yeah, if you can just get my window of sharing.
Yeah, we could see your taskbar, but just the PowerPoint window. So.
Okay, give me 1 second. Let me fix this quickly. Yeah, it's just Mac sometimes it doesn't let me do things the way I would like to. Okay, I think this should fix this. Okay, let's try again.
I love the one where you try to share and then it asks you to reboot your computer or something, or reboot the window.
I hope that doesn't happen.
I'll be back in 10 minutes.
Okay, so I think now we should be good.
Okay, we can see your PowerPoint again.
Okay, perfect. So let me log through the use case, and then we'll jump into the console and see what I have in there.
Okay.
So the use case here is restricting overlapping VPC CIDR, right? So the idea here is I have this hybrid setup with my tunnelless connect and my SD-WAN appliances connecting to my on-prem offices or whatever. And then I bring in a new office. I acquired it, and it has an overlapping CIDR 172.16/16, right? And that's exactly the same as my VPC. So one of the strategies is, let's add a secondary CIDR into our VPC, and then let's only advertise the secondary CIDR back on-prem, right? So here I'm going to do that. And then I won't go into the details, but you can put a load balancer in that 172.172 range, and then have your actual targets, actual EC2 instances or clients as targets of the load balancer or whatever. Right? There are several strategies to work in this scenario, but the main goal is I want to filter on 172.16 and only advertise 172.172. Okay. So this is my policy. So primary and secondary CIDR will be learned from the VPC. I'm going to filter the primary CIDR and only advertise the secondary CIDR to the on-prem network. Okay. Now, what I want to, this is, pretty straightforward. You match on the primary CIDR and you drop it. Right? But what I want to discuss here is the distribution point where you could apply this. So your option 1 is to apply the match on the primary CIDR and drop as the route is ingested into the dev segment, right? So you apply it on the VPC attachment inbound into the CNE. So if you do that, the route is never inserted into the dev segment. So not only does the on-prem not learn about the primary CIDR, none of the other dev VPCs understand or learn about the primary CIDR, and you might not want that. So your other option is to apply this route filter at the segment sharing between dev and hybrid. Right? So when you do that, this route is learned by the dev segment, so other dev VPCs can reach the primary CIDR, but hybrid segment is not able to do it. Now, this might be perfect, or you might have other hybrid segments. So here we have just SD-WAN connectivity, but let's say you have IPsec site-to-site VPN to other offices, or you have direct connect into your data centers, and you want those remote networks to access the primary CIDR. Then you have option number 3, is where the route gets inserted into the dev segment and is shared by the hybrid segment, but you apply the route filter on the tunnel-less connect attachment. So only the SD-WAN appliance does not learn about the primary CIDR, but everyone else does. Right? So this becomes really important on where exactly, which distribution point do you apply a certain routing policy. Right? So you need to keep that in mind. In my example here, I am going to apply that on option number 2, which is dev to hybrid sharing. And here's an example policy, right? So the policies are very intuitive. You define a policy direction. Direction is important. Here it's outbound because it's dev outbound to hybrid. That's the sharing direction. You define a match condition, prefix equals 172.16.00/16, and my action is drop. Pretty straightforward. And then I need to apply this to a route distribution point. So as I'm sharing dev routes with the hybrid routes, I'm going to apply this routing policy, right? And that's all you need to do. So now when you do this, as routes are being advertised from dev into hybrid, that primary CIDR will be matched and will be dropped, and hybrid segment will not learn about this specific route. Hopefully that makes sense.
I think this is just so similar to traditional networking where you would have an outbound prefix filter list applied on a BGP session or something similar, right? This is exactly what we're doing here, and it's just so intuitive yet so powerful. This makes a lot of sense to me. I think this is a fantastic feature. I'm so glad we did it, and I'm actually thinking, why didn't we do this back when we launched Cloud WAN?
Yeah.
I get it. It takes time, but these things aren't easy to build. They're quite difficult. But yeah, this
Yeah,
feels like a day one thing that would have just been so great.
exactly. Um, so let's talk about another use case, right? So this use case is restricting a VPC cider propagation across regions. It is a very common scenario as well, where in EU West 1, in the European region, there's a lot of compliance regulations. So here, let's say you have this 10.200/16. It's a VPC in the EU West 1 region, and you want to restrict it to be restricted so that it's only accessible within the EU region, and the US East 1 VPCs cannot access it. So as the traffic is learned by the CNE in Europe, and that route is advertised cross region to US East 1, you filter that specific route. Right? So how can we do it? So we create an outbound route filter to drop the VPC cider, right? Match on the VPC prefix, action drop. And then we filter the routes on within a segment cross region sharing. So again, let's look at the policy. Um, we match on the prefix and we drop it. Pretty straightforward. But now, instead of applying it like in the previous example, we're applying it in segment sharing. Here we'll apply it to cross region sharing within a segment. So here you can see I associate routing policy into the segment prod, and I'm saying apply the routing policy filter EU to US as the routes are being advertised from EU West 1 into US East 1. And if you have other US regions, you would repeat the same. So I'm saying for prod, apply the same policy also as the routes are being advertised from EU West 1 into US West 2, right? And that's it, right? So once you do this, my EU routes will be fully isolated in EU West 1, and they will not be advertised to the US regions.
So there's a question here from Ken. What about service insertion? Since there's static routes when you apply the policies. Thanks, Jeff.
That's a great point. Service insertion takes priority. So when you set up service insertion, Cloud WAN behind the scenes is inserting static routes. And static routes take preference. So I do have a slide on that.
I guess we needed and we have always had some form of administrative distance. Right, on a typical router, you would say admin distance of a static route is 1, I think it is, and eBGP is 40, and what's iBGP? I don't know, like 100 or something. It's less preferred than eBGP, but in this case, there is a form of preference, not specifically admin distance, saying static route prefer that, dynamic routes less preferred.
Exactly. So since we're talking about that, let me just bring that slide up, right? So this is how Cloud WAN evaluates route at a CNE, right? So the CNE is where the decision is being made. It's learning routes via BGP. You may have configured some static routes. You may have configured service insertion. You may have applied some routing policies. The CNE, when it learns everything in its RIB, before that RIB is before it takes the information in RIB and puts it into the FIB or the forwarding table, it evaluates things in this order. Obviously, the most specific route always wins. Now, for routes which have the same destination addresses, destination IP address, but has different targets, static routes always win. Now, this static routes can be created by you as an end user, as a network admin, or it can be part of Cloud WAN automation, right? And that's where service insertion comes in. So if service insertion has been configured, service insertion inserts static routes into your route tables, and those are like transparent, like you can see them, what's being inserted. They take priority. Then the second priority is VPC propagated routes in the same region. Right? So the VPC routes win. If it's not a static route, if it's not a VPC propagated route, then comes the dynamic routes, right? So for dynamic routes, we're just following what the BGP RFC states, which is local preference takes highest priority, then AS path, and then MED. Now, if everything is same, right, you get dynamic routes with the same local preference AS path and MED, then direct connect gateway propagated routes take priority. Second priority goes to Cloud WAN connect propagated routes, right? So that's the SD-WAN connectivity. Third is site-to-site VPN. By the way, keep in mind that these are in the same region. And then the last is route propagated from transit gateway peering and core network edges in other remote regions. And if identical routes are received, like everything is same, even like nothing matches here, then what we'll do is we'll choose one route at random, but it'll be deterministic, which means that'll always be the same deterministic option. Right. So this hopefully clarifies how the CNE is going to read the RIB and then put it into a FIB based on sort of these priorities here.
So we don't explicitly have an administrative distance that we expose here. Now, the reason why that might be, and Sid, help me here, but I'm just assuming, would be that these aren't configurable. These are set in stone on how the platform operates. And I imagine if, and I don't know if this is actually something that's going to happen or not, but I imagine if we were ever to have it where you could change the priority of these routes, we would need to have some form of numbering / metric / admin distance, right? So that's probably the reason why it's not shown there or not available for you to see.
Yep, exactly. This is set in stone, at least for now. Nothing is set in stone forever, but yeah, it's not configurable. This is something which you should be aware of and plan around.
It'd be cool if we could change it. There's a question from Tech First. When we apply the policy, will it warn the user what exactly it's going to do to avoid any unintentional outage due to lack of understanding of inbound, outbound segment attachment combination, et cetera, et cetera?
That's a fair ask. It doesn't have the smarts to figure out if you're going to mess up your routing. Obviously, in Cloud WAN, it is all through routing like it's through the Cloud WAN network policy. So when you do implement a new policy, there is a change set, and it tells you exactly what it's going to do. That it's going to add a route here, or it's going to add some filter here, etc. So you know what change is going to happen compared to the previous policy, but it does not have the intelligence to know how that's going to affect your overall network from a routing standpoint. Maybe you can use AI there, as part of your deployment, have Claude via Bedrock read your policy and tell you, because I did that. Like I did a demo of using routing policies at the re:Invent session, and one of the demos was to use Claude to understand my network and generate a routing policy for me for a specific thing. So it's pretty smart there. So maybe you can use
How
some
did
of
it
the
go?
AI.
Was it
It went well,
pretty
actually.
accurate?
Yeah,
Oh,
it was
excellent.
pretty accurate. Yeah, it was pretty accurate.
I
It just needs.
recently saw a internal session around using AI encoding, and there were some claims that we could greatly increase our speed of operating by using things like Claude, and I believe it too. I think for use cases like this, man, there's so many opportunities there that we just haven't tapped into yet.
Yeah, exactly. And I can actually show you. Well, maybe not today, but if you do another session on the demo, then I can probably show you guys that
I
as
think we
well.
should, we should have a bunch of those sprinkled in.
Let's do a time check. We have 10 minutes. So
10 minutes.
I have another example here, which is it's a slightly more advanced example. I may not know going deep into it. I'm just call it out so that you know that this is possible, and then maybe we'll use some of the time to jump to the console and quickly have a look. Obviously, we don't have time for full-fledged demos. So this example here is for route isolation from hybrid into prod and dev. So as you can see in my setup, on-prem sites are connected to my SD-WAN appliance. And from my SD-WAN appliance, I am advertising two routes to my CNE. They are color coded differently. So 64.10 is in red, and that's my production route. And on-prem systems are in that range. And 64.20 is my dev route, and my on-prem dev systems are in that range. Right. Now, what I want to do is, as I redistribute routes from hybrid into production and hybrid into development, I only want the production on-prem route to be ingested into my production segment and my on-prem development route to be ingested into my development segment. Now, prior to this routing policy feature, it was all or nothing, which means if you shared hybrid with production, it would learn both the on-prem routes. And if you shared hybrid with development, it would learn both the on-prem routes. But now we can change that. And here, I will not match on a prefix. Rather, I'll make it more dynamic, and I'll match based on a community. So what I'll do is, on-prem router, as it's advertising the routes into my SD-WAN appliances, I'll tag 64.10 with a community. Here it is 65,100. And I'll tag my dev routes by 65,200 community. Then I'll write a route policy to match on these communities. So I'm not matching on prefixes. So my prefixes can be dynamic, right? Tomorrow I can add or remove prefixes. I can change prefixes. Doesn't matter as long as I'm tagging them with this community. I'll match the 65,200 dev community, and I'll match the 65,100 dev community, and I'll use that to redistribute routes into my production and development. Right. So this I
This
can
is the
apply
kind of
again. Sort of
networking I've
use
been
this
talking
logic.
about for a long time. Sorry,
Yeah.
Sid.
No,
Like
that's
this is what we need, right? On-prem, you just tag a community, and you have an outbound prefix filter list that says,
yep.
hey, these are my prod routes, these are not. Tag this community, and then everything just happens. You don't need to go into your Cloud WAN configuration and start goofing around and limiting routes or anything. It just happens. It works. It's magic.
Exactly. Yeah, and that's the beauty, right? Because the previous examples were matching on prefixes, and we know prefixes change all the time.
Yeah.
We add, remove prefixes. So I think communities is a much better way of doing it. The only thing is the community matching and tagging support is a bit restrictive at this moment. As I said, Direct Connect is not yet supported. VPC attachments is not supported, so it's only supported on like this, the VPNs and the SD-WAN. But of course, we are adding support all the time. So things should change in the future. But yeah, this is the way to do things going forward. So I have like detailed policies on like how to set this up, and also demo. Again, I'm not going to go into detail there just because we don't have much time. I do want to quickly jump into the console, and maybe let's just look at.
Well, while you're bringing that up, Ken just had a question. I think it was when we were talking about AI. If we're covering things via an AWS Cloud WAN and MCP server, I don't know. Do we have an MCP server or something? I mean, you would have to have an IAM integration for an LLM to be integrated to your AWS console, right?
Yeah, we don't. I don't think we have a Cloud WAN MCP server yet. But we do have an AWS MCP server, which gives like Claude. I use Kiro with basically any AI to make AWS CLI calls and API calls. So that's all you need really, is a capability for AI to make AWS calls. Okay, cool. All right.
I think Tech Fuel, you posted a question mark. Maybe just clarify the question. I think. Oh, sorry, you did post something. Could we do these checks using Kiro CLI? I believe so, right? I mean, you would have Kiro log in through your IAM credentials, and then it should be able to do those checks. We should do a session on that, because honestly, that's a very powerful thing to set up.
Yeah. So this is my reInvent session. If you search reInvent 25 advanced routing policy.
Oh, I posted it earlier in the chat.
Okay,
so
you posted
link's
earlier.
there
Okay, perfect.
Yeah. Mm-hmm.
So all of the use cases I mentioned along with demos is in this session. We can obviously do this, do the demos deep dive next week if needed, or sometime in the next month or so. But for now, let's just look at the console quickly. Maybe I'll just make it a little bigger. So I have my global network. Jump into the core network. All right, let's just make sure. All right, this looks good. You can see the rib new here, but before I go there, let's look at the topology tree. I just want to make sure I have the right setup here. Hybrid VPCs attachments. Okay, cool. Just hybrid connect peer BGP is up. Okay, so I mean, it's a very standard setup, very similar to what you were seeing on the slides. I have like US East 1, EU West 1, US West 2, a bunch of segments, hybrid, dev, prod,
Hey,
and
Sid,
then I have.
do you want to just
Yeah.
reshare and just reshare your tab as opposed to the browser screen? Might just help make it a bit more zoomed in.
Oh, Zoom. I
Maybe
can.
well, we want to cut out the account details at the front, at the top too.
Oh yeah, I can just do this.
That works. Yeah. Okay.
Yeah. So basically, in the time we have, what I want to show you quickly is if you go into. Now it's so zoomed in. Is the routing information base, right? So here you go into routing information base and you select a segment, let's say prod US East 1, and get routing information. And now you can see I have this whole bunch of routes, and some of them are next hop is like local attachment. This is my connect peers. This is my SD-WAN peer. I'm getting routes from US East 2, US East West 2, and it also shows you like what the AS paths are, the MED community. So you can see the 65,100, 65,200, right? I was talking about these. I'm tagging this from my on-prem, and then I'm using these community values to filter and push routes into my forwarding table. So this is something which you can go and explore and see exactly what's going on. And now if you want to see the forwarding table, that's basically just the standard routes. So you go into routes, and the same thing, prod US East 1, search routes, and you can see I just have like 4 routes, and they had like 100 routes there, right? So that rib gets filtered into these 4 paths. So it made a decision saying for 10.1, I'm going to use next hop US West 2. For 10.2, I'm going to use US East 1. When you see something like this is basically a CNE in the other region. And then for the other 2, it's going to use these. And several routes are getting filtered because of my policies, right? So, and the policies, you can go and check the policies here. Here you can see there's a new routing policy, and I have like 7 policies here. 1 to summarize prod VPCs, the depth to hybrid route filter EU to US. I showed you an example of that. Here I'm matching like hybrid communities for prod dev, and I'm setting like route preferences here. So you can see I have like bunch of like policies here. So I know we are sort of at time today, but if we do another session, I can sort of go into the details on what these policies are, maybe make some tweaks, changes, and see what happens. But that being said, go watch the reInvent session that has a lot of these details. It should give you a good idea on what's going on and how you can set some of these as well.
Very cool. All right. Well, we're at time. This has been amazing. I think this has been a great start to the year. I love this feature. Really want to see what we can do with this thing in the future. So I'm sure we'll be doing another session on routing policy for Cloud WAN. I think this also adds a whole bunch of reasons to use Cloud WAN over Transit Gateway. Before, I think it was, you could do either, but this is a very powerful set of features. So thanks everyone for joining. Sid, thanks for coming on, man. Well,
Yeah.
we'll have more sessions as we go out throughout the year. So good to see everyone again. Thank you.
Yeah, all this fun. Thanks, everyone.